Hey guys, so another physics video, cause why not? Oh my god, physics is too cool. So I've talked about quantum mechanics, ENM, and maybe classical mechanics on this channel. I'm pretty sure I've talked about classical mechanics, but I haven't talked about statistical mechanics yet. So let's talk about statistical mechanics, because statistical mechanics is so freaking amazing. Okay, I mean, it's still my least favorite branch of physics, but my statistical mechanics professor really did a good job this semester just selling statistical mechanics as, you know, something that you shouldn't really hate. And actually, statistical mechanics is the foundation of thermodynamics, which, you know, like all the engineers take entropy or work and heat just for granted. But essentially what we did this semester in Stat Mech, that's the physics short version of saying statistical mechanics. In Stat Mech, we started from the fundamentals, we started from the math, and we built the theory from mathematical models of the world. And I liked it. I really did. I feel like that's what attracts me so much about physics, is understanding where work comes from, where heat comes from, you know, where entropy comes from even. I mean, sure, I still don't fully understand entropy, but now I kind of see entropy as this thing to do with probabilities. For me, probabilities make more concrete sense than this disorderness. You know what I'm talking about? But yeah, so a good professor can really make all the difference. I think I understand Stat Mech now. I really do. We did get into a little bit of quantum information at the end of Stat Mech, and that was insanely weird. And I mean, quantum mechanics is weird, like, just live with it, deal with it, it's fine. I don't know, does anyone understand quantum mechanics these days? So in classical statistical mechanics, the entropy is defined by this. Pn here is the probability that you'll find the system in state n. So let's say we have this 3-state setup, and if you're certain that your system is in a given state, then your entropy is 0, because the probability of you finding the system in that state is 1, and the probability of you finding the system in the other 2 states are 0. And if you're not too sure where your system is, that's when you get the entropy. But in quantum mechanics, when you collapse the wave function, you become more certain that your system is in a certain state. But collapsing the wave function actually increases the entropy. What? So, I mean, that's one of the weird things about quantum information. But yeah, no, Stat Mech, after this semester, I think I'm starting to appreciate what goes into Stat Mech. And it's not just, you know, the memorize a bajillion thermodynamic properties, because that just happens to be what engineers use and what we think of as useful. I mean, for me, I'm satisfied with this mathematical construct, which is probably the reason I'm a physicist. But you know, I could see the engineers just like not liking the math build up and actually want to know like, how is it useful? And I'm just like, yeah, what, like, yeah, sure, entropy, whatever, it's useful. Actually, the second law of thermo literally comes out from this graph. Not even joking. The red line is always above the green line, therefore entropy always increases. Bam! Because you get something along the lines of the change in entropy equals the red line minus the green line. Yep, math! You're welcome, I totally just taught you thermodynamics. Yep, cool. Okay, well, see you guys next week. I am packing right now, which is why we are filming at this random angle. I took down all my posters, so my old angle was a little blank. Actually, I'm looking at my old angle right now. But yeah, no, I've also finished all my academic requirements, and now I'm basically just waiting to graduate. I still have to wrap my project up, but, you know, waiting to graduate. And then I finally get a summer break, and after the summer break, it's going to be 5 years locked up at Cornell. Okay, not locked up, but you know, grad school, yeah, whatever, right? I'll have fun. I'm excited and scared. Mostly excited though. Okay, bye guys.